Assalamu alaikum students. The topic for my today's video is resistance. Resistance is similar to friction. Friction is an opposing force. It opposes the motion of an object. It acts in opposite direction to the motion of the object. In that same way, resistance is also an opposing force. It also opposes the direction of an object. The two types of resistances are air resistance and water resistance. Let us see what do you mean by air resistance. As I said, resistance is a type of friction. Resist, to resist something. Yes, to oppose something, to stop something. Yes, allowing it to stop. Yeah, making an object difficult to move. That means it resists. So now here in air resistance, air resists the motion of the objects. So when an object moves through air, there is a force acting on those objects. That force is called as air resistance. For example, if an aeroplane is moving in the air, the particles, the air particles, they hit against the aeroplane and it makes it difficult for the aeroplane to move through the air easily. Okay, that is why fuel and a lot of energy is needed for the aeroplane. So air resistance acts in opposite direction to the motion of the object. So here, let's see in this image, here the aeroplane is moving to the left. Yes, so forward speed, the motion of the aeroplane is towards the left. So air resistance will act in the opposite direction. It will be towards the right. Now since air resistance, it hinders, it opposes the motion of the objects which are moving in the air. So there are different ways where we can reduce air resistance. Okay, air resistance cannot be stopped completely because air is everywhere around the objects. Yes, the ones which are in the air. So but we can avoid or we can reduce air resistance. And how that is done is, that is called as streamlining. Streamlining is the shape where the vehicles are narrowed from the front so that they can move easily in the air. Air resistance is a type of friction. It occurs when the object is moving in the air. Now let's see these two images here. In the first one, the vehicle is somewhat flat at the center, okay? But if you see the second image, the car is narrow in front. That means it is streamlined. Now what is the streamlining? It is actually you reduce the area where air resistance takes place. So if the area exposed to air is reduced, the air resistance will be reduced and the speed of the vehicles will increase. The vehicles can move at a faster rate. So here if you compare the upper vehicle and the car which is down, the car which is down will speed up more than the vehicle which is up, because the second car, the blue car, is streamlined. So if it's streamlined, the surface which is exposed to the air that is in the front, you call it as bonnet of the car. If it is narrow, the air resistance is less. If If it is broad, the air resistance will be more. So here with the red arrow in the first image it's given, the air resistance is 400 newtons. Yeah, the vehicle is moving towards the left, but the air resistance will act towards the right, shown with the red arrow. And the resistance for the vehicle which is up is 400 newtons. But if you see the car, the blue car which is down, again the blue car is moving towards the left, so air resistance will be towards the right. Therefore the arrow, red arrow, is towards the right. So here the air resistance is 300 newtons. So you can see that how streamlining helps in reducing air resistance. So if air resistance is reduced, the object can move at a higher speed. Now, cyclists, they can also reduce air resistance. There are two ways in which cyclists can reduce air resistance. The first way is they crouch down. Okay, they bend down. As you can see in this image, the boy is bending down, he's crouching down, and then he's riding the bicycle. Okay, in this way what will happen? If it's straight, more body part will be exposed to the air, so more air resistance will be more on that boy, so his speed will be, he'll find it difficult to ride forward with a higher speed. But if he crouches, air resistance reduces, and then he can, it makes him easy or simple to increase his speed. Another way, the forehead, the head which is exposed in front of the air, the front one there, if he's using the helmet, if the boy is using an helmet instead of using a round helmet, a streamlined helmet can also be used. So streamlined helmet again reduces the area of exposure towards the air, and air resistance decreases. So these are the two ways in which a cyclist can reduce air resistance and he can increase his speed. So resistance will be less. When resistance becomes less, the speed becomes more. Here in this image, again, it is a racing car. The image is of a racing car. So why not racing cars are made like trucks? Yeah, flat in the front. Yes, if you try to recall the making of a truck, how is the front portion of a truck? It's flat. Yeah, that is why trucks are heavier. Yes, they cannot move at a high speed. So are trucks taken in racing cars, in racing? No, in racing competitions cars are taken, and that too not ordinary car. These cars are something like this, more narrower in this front. That means they are streamlined. If they are, the more they are streamlined from front, the less will be air resistance, and the vehicle can move with a higher speed in the race. So this is streamlining. Another name for air resistance is drag. So here in this image there is a parachutist, and he has opened his parachute in the air. As soon as he opens the parachute, what happens is, suppose he's in an aeroplane and he jumps off the aeroplane and he opens the parachute. What happens when as soon as he jumps from the aeroplane, he will come down with a very high force, and that force is nothing but gravity. So gravity will pull him down. Gravity will pull the parachutist down with a very high force. But as soon as he opens the parachute, what will happen is his weight will be balanced by the parachute, and that balancing is done by air resistance, that is drag. And always, as I had said, that it is always in the opposite direction of the motion. So the parachutist is coming down, so the pull is downwards, So air resistance will be in opposite direction, that is, it will be up. That is why air resistance, the push of air resistance, the arrow is shown up. So air resistance also acts on the objects which are in the air, which are on outside in the surroundings, where the objects are exposed to air. Let us see what do you mean by upthrust now. So we are done with the air resistance, and the another concept which I'll show you now is upthrust. When any object is on water body, there is a force which acts on the body. It is on the body. Okay, that force is called as upthrust. What does this upthrust do? It balances the weight of the body. So any object, whether it is on the earth or on the ground or it is in water, gravity pulls that object downward. So here in this image, if you can see there is a ship, and that ship is, the force of gravity is acting on that ship in the downward direction, shown with the red arrow. So there is a force which has to balance this gravity, otherwise the ship will sink in the water, it won't float in the water. So why does a ship float on water? The ship can float on water because of upthrust. This upthrust is a force which acts on the body which is in the water, and it balances the force of gravity which acts in the downward direction. So here again, gravity and upthrust, they are in opposite direction as it's shown in the image here with red arrows. So the gravity is pulling the ship down while the upthrust pushes the water up, and this so happens till both the forces are balanced. Gravity is balanced by upthrust, and then only the ship can float. The ship floats. Let us see now what is water resistance. Now, if an object is moving on the surface of water, there is a force which acts on the object, and that force is in opposite direction to the motion of the object, and it is water resistance. So if objects are in the air, it is called as air resistance. If they are on the earth, they are on the land, it's air resistance. But if the objects, the things are on water, then water resistance acts on those things. Like you can see in this image, there is a board, and with the black arrow the direction of the board is given, and it is towards the right. So the board is moving towards the right. There will be a force which will act towards the left, and that is water resistance. So why does the boat have difficulty to move in the water? Why can't the boat speed up? This is because the speed of the boat, it is getting stopped, slowed down. The speed gets slowed down because of the resistance of water. So water particles also hit the objects which are in the water, on the water, and in the water and on the water, and they reduce the speed of those objects. That is water resistance. So because of water resistance, we have difficulty in walking through water. Why is it hard to walk through water? It's very easy to walk on land because air resistance is very less. Our legs are thin. The surface which is in contact with the air, it's very less. So air resistance is less, so we can speed up. We can walk faster, we can run. But if we are trying to walk through water, what happens is our whole legs get covered with water. So water particles we are moving towards in this image, the girl is moving towards the right. So what will happen? There will be resistance of water which will act towards the left and try to force the person to, it will resist the motion of the lady, of the girl. So what will happen? The girl cannot walk through easily through water. This is because of water resistance. Now, as I said, water resistance takes place on the objects which are on the water and also the objects which are inside the water. So, what happens when a person is swimming? When a person is swimming, he finds it difficult. Yeah, he has to exert a lot of pressure to move forward in water. Why is this so? Because water is everywhere around the body, the person's body. So, what will water do? Water particles will hit the body and water resistance will act on the body of the person. Yes, now if in this image the boy is moving towards the right, he's swimming towards the right. So water resistance will act towards his left, in the left direction, and obstruct, yeah, reduce, obstruct or oppose the movement of the boy. So now, as in to reduce air resistance, streamlining is done. For while swimming, streamlined position can be taken. So because of streamlining position, what will happen? The water resistance will decrease. And if water resistance decreases, what will happen? The person's speed can increase. Yes, so in the first image, you can see the position of legs of the boy. Small drag is streamlined position. So what did the boy do in the first image? He streamlined his body. Yeah, he has made his body streamlined, taking a streamlined position. So as soon as he makes his position streamlined, water resistance will become less. And another name for air resistance and water resistance is drag. So in the first image, it's written there is small drag in streamlined position. So in this position, the person can swim faster. But if you see in the second image, the position of the boy, yes, here what has happened? He has raised his face. So what has happened? Arms, hands are also raised. So the surface, which is the part which is exposed to water, has become more. So if the exposed part is more, the drag, that is water resistance, will be more. So that is why in the second image it's written large drag in unstreamlined position. So in this way, streamlining helps to reduce air resistance and water resistance. So if resistance is reduced, what will happen? The movement of the body takes place very easily and the speed can be increased of the object. Thank you.